morning. This is Alan talking to you on the 25th of May, and the purpose of this lecture is to address solutions to the homework that I've assigned in Chapter 2, that was problems 1 through 6. I'll flash it up here for you in a moment, okay? I want to take you as far through 1 through 6 as I can in this first recording. I may have to break it into two pieces, again, to contain my file size, or I can't post these things, okay? The very first problem that I gave you all to try in Chapter 2 was this one, where you invest. Let me make that a little bit bigger for you. Okay, and I am going to post the worksheet that we use here for this miniature lecture. So if you have a little trouble reading it now on screen, you'll be able to download it and call it up and review it in Excel yourself, okay? So the first problem says you invest $2,500 now for 3 years. You're going to make the investment now. Obviously, that is the present value, okay? And you're going to do that for 3 years at 8%. So whenever you do a time value of money problem, ladies and gentlemen, generally, and I'll make exceptions to this later on in the chapter, but generally what we need to do is we need to know an amount, we need to know an amount of time, and by the way, let me rephrase that. You need to know an amount of money, you need to know an amount of time, and you need to know an interest rate with which we either compound or discount. Now, because we're moving from present value into the future, we're moving forward on the timeline, we are compounding. We're trying to find the future value, okay, given a known present value, an amount of time, and an interest rate. Okay, so I start in a very simple fashion by bringing us back to high school algebra, interest calculations. What is the value of your investment after 1 year? It's going to be worth the original $2,500 plus interest, 1 year, 8%. So whenever you solve a problem like this, friends, we know that it's going to be based on this magical formula that is at the hub of the great wheel we call time value of money calculations. Everything revolves around 1 plus I to the nth power, where I is the interest rate and n is the number of periods involved, okay? So when you're solving A, B, and C, not D, we're going to do it the right way, okay? A, B, and C are just illustrative. You're going to take the amount of money, $2,500 that you start with, and you're going to multiply it by 1.08. That's 1 plus the interest rate, 8%, 1.08. You take that 1.08 to the nth power. Now, order of operations is critical here. Don't multiply 2,500 times 1.08 and take that result to the nth power, okay? The nth power only applies to the 1.08. In the order of operations in mathematics, we always do powers, exponents, before we do anything else, okay? So, and of course, if I wanted to take everything to the nth power, I would have put it in parentheses, 2,500 times 1.08. So there's a little review of order of operations. Always apply the exponent to the interest factor and then multiply that whole thing times the $2,500, okay? So obviously in the first case it would be 2,500 multiplied by 1.08, and that would be to the first power. Anything to the first power is the number itself. So you stop right there. The result is going to be 2,500 times 1.08. So your money would be worth, and I'm going to put 2 decimal places on that for us. Let me try that again. Okay, 2,700. Okay. It's not letting me do it for some reason. Hold on, there it is. Okay, $2,700. Okay, in the case of B, where it is after 2 years, as you look back at our original question, B, what is the value of your investment after 2 years? Notice I'm not asking you for the amount of interest. I'm asking you for how much your investment is worth in total. Okay, that's going to be 1.08 to the second power. That's another fancy way or shorthand way of saying 2,500 times 1.08 times 1.08, okay? So if you math that out, 2,500 times 1.08 times 1.08, you would get $2,916, okay? All right, and we keep going. Now we're going to take it to the third power, because in question C, I ask you, what's the value of your investment after 3 years? Okay? And this is the last time I want to deal with multiplying something by itself over and over again. In the future, I'm going to use my tables. Okay? So if you were doing this longhand, you would multiply something times 1.08 and again times 1.08. Now it's starting to get tedious, isn't it? Okay, the answer is 3,149.28. Okay, now what we're going to do in D is we're going to do it the way that we shall do it from this point on. Okay, we're going to go to the first table, the first of 4 tables. We are dealing with 3 years, 8%. 3 years, 8%. Okay, how much money will you have? All right, which table do we use? We use table A because we're moving into the future and we're dealing with one investment only. I'll talk more about that in my upcoming lectures for Module 2, where we'll wrap up Chapter 2, okay? So this is the future value of a single amount. There is 8%, 3 years, okay? The factor is 1.2597, okay? So I take 2,500 times, I'm sorry, what was my number again? I just forgot it already. 1.2597. My apologies. Okay? That's a lot easier than multiplying something by itself over and over again, isn't it? So let's see what we get. 314925, 314928. All right, are we going to worry about the fact that we're off by a couple of pennies? No, we are not, okay? Again, the reason for that is because that 1.2597 is actually 1.259 something, something, something. I can demonstrate that for you by coming over here to this table and making that number bigger and bigger and bigger with more decimal expansions, okay? It's actually 1.259712, okay? And that is why we get rounding differences that we can certainly accept, all right? The second problem, problem number 2, is just a little bit of practice moving the opposite way on the timeline, okay? What is the present value? We know what the future value is, 8,000, 16,000, 25,000. We want to know how much we would have to invest today, once and once only, to get that number in the future. That's what present value means. This is about discounting, okay? So, $8,000, 10 years, 6%, okay? $8,000, 10 years, and 6%. Okay. What we're going to do is we're going to go over to which table? Table number 1 or A? No, that's moving forward in time. This time we want to move backward. We are going to use table 2. And I'll give you a couple of pointers about selecting which of the 4 tables to use in my next lecture in Module 2. Okay, this is the present value of $1, a single amount. Okay, well, I'm looking not for $1, I'm looking for $8,000, so I just look at my factor here, 10 years, 6%, and it's going to be on line 16, okay, 0.5584. These numbers in table 2 will always be less than 1 because we're looking at how much will grow to be $1. It's obviously going to be less than $1. So the number I want, 6%, 10 years, is going to be 0.5584. Okay, so let's use it right here, 0.5584. I'm going to multiply it by $8,000, and I'm going to get 4,467.20. 4,467.20. That is how much I invest today. That will grow to $8,000 if I lock in 6% per year and compound it for 10 years. Okay? So that is my first answer. All right. Item B says what? Item B says, what about 16,000, 5 years, 12%? Okay. Simple enough. When you've done one, you can do them all. But I'm going to take one of them, and I'm going to prove it for you. Okay? We'll get to that in a moment. 5 years at 12%. Will be, come way out here to 12%, it's 0.5674. Multiplied by how much? Times $16,000. Okay, it's that easy. 0.5674 times 16,000 gives you, let's try that again. Okay, I am having some trouble here. What is the problem? For some reason, it's not taking my decimal point. Let's try that one more time. 0.5674. I think I was just trying to type too fast. There we are. $9,078.40. If you invest that today, it will grow to $16,000. And finally, item C says what? It says 25,000, 15 years at 8%. Okay, I forgot my number already. 15 years, 8%. Okay, maybe that's the number that I'll prove to you, okay? All right, come on out here to the table. Table B, or table number 2. 15 years at 8%. Okay, my answer is going to be on line 21, it looks like. 8% will be, there it is, 0.3152. Okay, multiplied by $25,000. I'm having a bad typing day today, apparently. Okay, 25,000 times 0.3152. My answer is going to be $7,880. Let's do a proof on that one. Let's do a proof of C. Okay, whenever you do a proof, you're going to take your years. And by the way, your proof will change a little bit for more advanced problems. We'll deal with that later. What is the amount of interest every single year, and what is my running balance? Okay, I believe, and let's put down here, if I invest $7,880 today, okay, and I'm going to do that for 15 years, so I'm just going to grow this number out for 13 more years. That's going to give me line 35, I think. Yes. Okay. My interest is going to be, every single year, I'm going to take my running balance from the preceding year that I ended the year with, okay? I'm going to multiply it by 8%, 0.08. In the first year, I make $630.40. I want 2 decimal places on all my numbers. I don't know why it's not letting me expand my decimals today. There we go. Now I've got it. I know what I was doing wrong. Okay. By the way, as an aside, earlier this morning I signed everyone in this class up for my Excel badge course. So if you would like to pick up some proficiency in Excel, if you don't already have it, if you do, if you'd like some practice, especially on higher functions, consider going for the badge. It's a credential that you can append to all of your personal data, okay? Along with a letter from myself certifying that we approve you as having taken the course, and it is for free, okay? All right, so how much money do you have at the end of year 1? You are going to have how much you started with plus 1 year of interest. You're now going to have $85.10. I'm going to do the same thing for 14 more years, all right? And there is your proof, ladies and gentlemen, okay? Plus or minus a few bucks, your 7,880 has grown to 25,000 if you give it enough time, okay? So that's problem number 2, a little practice in how to do present valuing. All right, let's take a look at problem number 3. Okay, problem number 3 says, okay, you've got a choice. Your aunt is testing what kind of a financial whiz you are, so she says to you, I will either give you $45 today, and or you can wait, and I will give you $20,000 instead in 50 years, okay? Now you need to know time. You know time, 50. You need to know a rate, 13%. Can you compare $45 to $20,000? No, 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 absolutely not. You cannot compare a number in the future to a number today. They are not comparable. You've got to put them on the same playing field first. Okay? We get those numbers on the same playing field by calculating the time value of money. What will it take to make that $20,000 comparable to $45 today? Okay, so I'll tell you what I'm going to do. I'm going to take the $20,000 50 years from now. I'm going to discount it to today and see how much that $20,000 is really worth. Can it be comparable to $45? Of course it can, because time and an interest rate will work its magic for you. So 13%, 50 years, okay? All right. Once in a while, a student will say, well, couldn't I take the $45 and future value it, grow it into the future? The answer is yes, you could. The thing is, financial analysts and accountants like taking future values and discounting them to today. There's a business reason for that, and we'll get into that in a future chapter, okay? So what we're going to do is we're going to take any future numbers and discount them and make them comparable to that $45. Okay, the amount of money that we're dealing with, again, is $20,000. So I'm going to come over here and take 50 years. That's the last number we see in line 40, okay? This is, again, the present value interest factor table. And I'm going to go over to the 13% column, that is column O, and I'm going to use 0.0022. All right, 0.0022 multiplied by $20,000. That's going to tell me, okay, how much that $20,000 is worth in today's money. Okay, let's actually math it out and see what we get. 20,000 times 0.0022, and I'm going to put decimals on that. Looks like 44 bucks. That's interesting, okay? In other words, your aunt is saying you can have the equivalent of $44 today, or you can have $45 today. Obviously, you'll take the 45, right? It is bigger than the present value of 20,000 in the future, okay? When you've got enough time working for you and a big interest rate on top of that, the bigger the amount of time and or the bigger the interest rate, the more significant the effect, okay? All right, if you would like to see a proof of that, let me know. I'll happily send you one. And by the way, I made this offer to one of you already. I'll repeat it to everybody. Okay, if you want more problems, more challenges, more examples, I'll happily provide them. Drop me a note and I'll write a few up for you and send you the solutions as well, okay? I'll be more than happy to do that for you. All right, very good. The next one I asked you all to try was number 4, okay? And I did have some questions on number 4. Let's go take a look. I'm watching my time here. I don't think I'm going to make it. Okay. You are going to receive $200,000 in 50 years. What is the difference in your present value? In other words, that $200,000 50 years from now, how much is it worth today? What's the difference if you discount it at 15% or at 5%? Okay? Whenever you do an either or, you do it both ways and then compare the two numbers and answer the question. Okay? So, it's $200,000 in 50 years. Okay? If we discount it at 5%, and if we discount it at 15%. Okay? I believe I got those numbers right. Let me check. 15 and 5. That is correct. So we'll do two separate calculations and see what happens. Okay, once again, are we moving forward on the timeline or backward? Well, we already know what the future value is, so we want to move backward on the timeline, discount it to its present value. That means we use Table 2 or Table B. Okay, so 50 years. All right, let's try 5% first. Okay, 50 years is the last number in my table. So come down here and we're going to multiply it by 0.0872. Okay? Then we'll do 15%. Come way over here. There it is, 15%. The factor is 0.0009. All right, it's that easy, friends. Let's see what we get. All right, the first one is 0.0872. The second one is going to be times 0.0009. Okay, there are my two numbers, friends. I'm going to add pennies to that just for grins. Oh, there are no pennies. Okay. All right, so what is the difference? That's what I was really asking you. The difference is going to be, okay, like good accountants, let's put lines under our numbers as we learned in financial accounting so long ago. Okay, and we're going to take the difference between those two numbers, and that's the answer. Our difference is significant, isn't it? Okay? Now, a student a couple semesters ago said to me, Professor Adams, rather than doing this, if you want to find the difference, instead of doing both calculations and subtracting, couldn't you simply take the difference between those two numbers, 10%, and multiply it by 200,000? No, you can't. Okay? Because multiplication is not additive and addition is not multiplicative. Okay? So finding the difference in percent rates and then doing one operation won't give you 17,260. Okay? All right. Common sense says it's going to give you $200,000 times 10%. That's going to give you $20,000. Okay? You can't do it. So this is how the calculation is done. That is your difference. And it is significant. See the difference between using a large interest rate and a small one. Okay? My time is up, so I'm going to save this and I'm going to do a second video lecture for you to wrap up the last couple of problems. All right, very good. That's it for the moment. Back at you after.